For this next example, we are going to look at how to calculate the mass in 0.1 moles of iron 3 oxide. So now again, what we see is mass and moles. The relationship between mass and moles is molar mass. So therefore, we must determine the molar mass of the substance that we are working with, which is iron 3 oxide. So if we are given the name, we must convert it to its chemical formula to determine the molar mass. So iron 3 oxide, again, we have a transition metal that has a Roman numeral. So the Roman numeral indicates to you the charge on the transition metal. So iron is Fe, and the Roman numeral 3 tells you that it's a +3 charge. Oxide stands for oxygen. And according to what we have learned on the periodic table, we identify that oxygen has a -2 charge. So now looking at these charges, we see that these charges are not balanced, +3 and a -2. So I'm going to show you my crossover method again. And that will show you how we can make this into a balanced chemical formula. So what I'm going to do is I'm going to take the 3 here, cross this over to become the subscript on the oxygen, take the 2 here, cross this over to become the subscript on the iron. So now what that gives you as your final chemical formula will be Fe2O3. So then now if we have 2 irons with a +3 charge and 3 oxygens with a -2 charge, then that gives us equal charges, +6, -6, okay? So they cancel each other out, okay? So this is our chemical formula. And now we must calculate the molar mass according to the elements present. So we have 2 iron and 3 oxygen atoms. So let's look for the molar mass on our periodic table. Looking at my periodic table on my desktop, I see iron has a mass of 55.85. So we're going to do 2 times 55.85 grams per mole. Okay, remember the atomic mass from the periodic table is numerically equivalent to the molar mass. Okay. And then 3 oxygens will be 3 times 16.00. Okay. You'll notice that I generally round my molar masses to the hundredths place, okay? So whatever you decide to do, if you use all the digits, that's fine, but I've decided to only go to the hundredths place. So just stay consistent with whatever you decide to do and always show your work so that I can recognize and give you credit for your thought process, okay? Now, when we add these masses together, we're going to do 2 times 55.85 plus 3 times 16. This is giving us a molar mass of 159.7. So that's telling us 159.70 grams of iron 3 oxide per 1 mole of iron 3 oxide. Okay. So here's our conversion factor. In order to convert between grams to moles, this is our conversion factor. So now let's see what is our given value in our problem. Our given value is 0.100 moles of iron 3 oxide. Okay? So we're going to start with that. 0.100 moles of Fe2O3. And we're going to multiply this by the conversion factor. If we're starting with moles and we want to convert to grams, we need to cancel the moles in the denominator. As the conversion factor is written here, we have moles in the bottom. So we're going to leave it as is. We're going to put 1 mole of iron 3 oxide on the bottom and 159.70 grams on the top. Now we cancel our units of moles and we're left with grams of iron 3 oxide. So now that our units have been canceled appropriately, we can solve with our calculator. 0.1 times 159.7 gives us 15.97 grams. 15.97 grams, and that is of iron 3 oxide.